Okay, hi guys. This is Team 10, and we are here to present you with our semantic project that is AutoGuide. So before actually jumping into the exact demo of our project, let's briefly discuss about what this AutoGuide is all about. So we face a lot of dilemmas and problems in buying and selling automobiles, and the parameters being a fair price, proper specifications, salvage title, establishing the authenticity of the corresponding dealer. So Automobile Guide is one application which tries to answer these questions. So Automobile Guide works statistically to scrape the required data regarding the history of the vehicles, their technical details, their general details, reviews, and analysis of automobiles. So Automobile Guide combines the data from different domains of automobile industry, government data statistics for crime statistics and automobile tracking, end user reviews, and other data sets such as classifieds platforms, the one being Craigslist. And we follow semantic web rules using ontologies and RDF concepts to establish meaningful data links and hence effective retrieval. So this application works on a well-researched different datasets provided by the federal government linked semantically, thereby establishing the authenticity of the data and the vehicle one is looking for. So automobile guidance serves the end user, be it a naive user, and he can check the general specifications, or an expert technician, and he can actually go and check the technical details of the vehicle. So let's briefly see like the tools and technologies used are the ones which are being used by mostly by the other teams as well. So we have used Python Flask at the backend, Apache Gina Fuseki server, Scrapy for web scraping, and the front-end technologies. And we have used Prodigy for ontology generation and Google Refine for data pre-processing and RDF generation. So this is our project workflow. We gathered the data sets, created the OWL file using Prodigy. Then using these two, we generated RDF using Google Refine, uploaded into Fuseki server, and created Sparkle endpoints. And then we worked on the application backend, and we queried this Foseki server using the Sparkle queries and the Sparkle endpoints, and we displayed the required data on the UI, and we used Flask for this thing. So we discussed about the data sets that we used, and coming to the backbone of our project, that is ontology. So this is our ontology design. We'll come back to this after breaking this down into individual parts of how our features of auto guide has been implemented using this ontology. So used cars available feature has been implemented using these following data sets, and we have scraped the data from Craigslist, and that data can be used to find the cars which one is looking for, and we can check the history of the certain like the cars which is similar data, their price and everything, which gives you a fair idea of the technical specifications and price, and hence helps you in making a right decision if you want to buy that car or not. So this is one of the most important features of our auto guide. Then similarly, we have performance feature, which scrapes different data sets to find out the performance of the old vehicles which have been there. So you can look up while buying a car, like how the vehicles like that have performed and whether you should go for buying that or not based on different parameters, which we will see in the demo. And we have used the following data sets for this thing. Similarly, we have specifications, and the interesting part is we have divided the specification into two parts. One is general and one is technical. So general specifications are the ones for the naive users like us, and if like we are really adept with the technical details, and we want to know the technical details of the vehicle we are buying or selling, so we can look up that and we can get to know more information about how that car is performing. And we can use these parameters as well to compare different cars. So we have implemented a functionality which compares three cars at the same time. So if you have a doubt regarding three cars, you just go out to our application, compare them, and buy the best one. So we have review cars, which basically tells you how that car is being reviewed out there in the public. And we have implemented this feature using the high level ontology of automobiles, that those being specifications, dimensions, fuel, performance, ratings, and price. Okay, so this is how all our ontology looks like. So the interesting part is these green lines which we can see in this ontology, because this is how we have established the links between different data sets, which was like really the tough part of this project, because these data sets come from very different data sources and we had to go through them to find these links and establish them so that we can query these data sets at the one time and get the required data. So this is our semantic data model. You can see this is how we generated the RDF. So we used Google Refine for dataset refining, did RDF mapping, and using refined dataset and ontology file, and created an RDF instance. Then that generated RDF, we uploaded to Apache Fuseki server and queried RDF using Sparkle endpoints and results. Uh, Okay, so this is how our web scraping is, like we have done it. So we have used Craigslist, and so without any further waiting, let's jump into the demo. So before going there, like, so this is our Apache Jina Fuseki server, and let's see. So we have, these are the datasets that we have uploaded into this server, and say for example we have to query a data. So we basically go, this is a combined data set that we have, and say this is a query we have. So if basically we get the manufacturer name, model, exterior, interior, comfort, liability, build, and overall rating, which is like one of the major performance issues. And let's see, if we run this query, we get very good viable results, and we get the model, manufacturing, which is mostly in this case AM General and Rolls Royce. We can see exterior ratings, interior ratings, comfort. These are out of 10 and has been combined through from different data sources. Liability, build, and overall ratings. So this can be used. These parameters can be used to actually make a right decision whether to buy a car or not. All right, so this is our code. So basically we have followed Flask, and then we have used Python in the backend. So just a brief overview about, we have used Sparkle Wrapper class and queried the Fuseki server. We can see, so this is the compare feature which we were talking about in the slides. So in the ontology, we saw the compare feature. So this is the query. So we compare different cars using the following parameters, that is exterior rating, interior ratings, comfort, liability, build, and overall rating. And this is how we have queried these things. So we have created 3 queries for 3 different cards, and we send it to our compare page, and the details which user have returned, that is manufacturer name, model, and the year. Another important aspect is the one which we were asked to implement, is the price. The pricing search that we have implemented over here. So this, we have put in filter of minimum price and maximum price, and we have implemented this pricing search in this thing. This was like what was required of us when we presented our project. So we have successfully implemented it. So let's jump into the presentation. So when we run our code, so this is our code running, and it has started, and we copy this URL, and so we open this in Firefox. Say, it's already working, but let's go again. So okay, so let's see, let's start with the performance. If you have to find a performance of a car, so let's say we have to find a performance of a car named Fiat, and say model is Punto, and I know this car, like this is a 2013 model, and let's search for it. Let's see what we get in the performance measures. The query is running right now. And here we are. We get the horsepower, model, RPM, and some manufacturer details. So these are the details which we are getting from the government dataset. So, okay, so this is our performance measures. Similarly, if we want to find a general specifications, we say go and query the make as GMC, and we model as say Yukon / hybrid. I've already searched it, and this was a 2011 model, and this is a used car, so we go for a used car, and now we submit the query to know the general specifications. So probably, if you find, say, so this was a car I found on listed on Craigslist, and I wanted to know the general specifications of this thing, which was not listed. So we can see the transmission is automatic, and combined fuel efficiency is there. We have a drive system, it's a rear wheel drive. Highway fuel average is 43, and city fuel average is 37. Important characteristics before buying a car, Okay, so if you want to get into more detail of a technical specifications, you can go to our feature of tech specs. And again, okay, so if you have to buy a car, I know a car, and say it's a Volvo, and the model is say V40. Okay, and yeah, so this was a 2012 model. So, and then submit the query to find out the technical specifications of this car. And here we are, like it's a four-cylinder car, its weight is this, its air aspiration standard, 3.5 strokes, and the symboling is like the how it's being rated in the market out of 5. So it's 2, it's not too bad, but we can do better. Compression ratio 9.3 and bore 3.62. Quite a bit of technical specifications, not much even I know about. So if you know about this thing, you can actually make a better decision. Going back to the home page, we can review cars, find the ratings of the other things. So in review cars, we have so we have to find the used cars. So we give the model again, say GMC. We found the reviews of the Yukon Hybrid. Let's find off the Yukon, which is a 2011 model again. Sorry, my bad. And we submit the query. We found out, let's see what we found out about this thing. So these are the reviews and ratings for this car. So okay, so this has, out of 10, this has been rated as 9.05 in comfort, 8.45 in liability, good build, good exterior, good interior, and overall ratings are pretty good. I would definitely go and buy this car if I get enough money. Nevertheless, going back, so this is one of the most important features. If you have to buy a car, you're confused about 3 cars. So here we go. So okay, I'm gonna put it to used because obviously I'm gonna compare the used cars. So let's compare the cars of the similar manufacturer. It's a GMC cars, and we have 3 models of that car. Say one is Canyon, the other one being Yukon. We just searched its specifications, and the third one being Acadia. Yeah. Okay, and this one I know it's a 2012 model. This one I know it's a 2013 model, and this one is 2011 model. So let's see which car we're gonna buy. Oh, we have 3 cars. Pretty confused between them. Alrighty, we have the 3 performance specifications. So see, okay, so we can see that there's a tough competition between car 2 and car 3. We have 9.05 comfort ratings, 9.37 here, 8.45 here liability. Uh, Exterior ratings are good in case of car 3, overall ratings, but in case of car 2. So basically, we can go for either of them, the more importance you give to it. So this is one important thing of our application, which gives you fair idea about which car you should buy. You can go and search for the price and everything. All right, going back to home. And now the one of the most important things, the price-based search. Okay, so this was what we were asked to implement, and let's say we have to buy a car, and our lower budget is like $2,000, and say upper is like 5,000, and we need the cars between these. So what kind of cars would there be? And here they are, best cars for the price. So we have models, cost, and manufacturer name. So you can go and search for these cars in the other data sets to get the more details, general or technical specifications, get the price of it. And you can go to Craigslist or any other website, classified website where you have found these cars and where you want to buy these. So before ending, so here is like where our used cars data is available. As you can see, we have plenty of used cars, and this data has been scraped from the Craigslist. So for example, if you have to go and buy, so we have the specifications of this car. This takes you to the Craigslist website. You can get to know like where it's available over here. You can contact the dealer and you can get the car. And so if you hover over it, you can see these details which you can put in an application and get to know more details about it, because even though these details might not be available on the Craigslist, but this is what our application serves. It is available on our website, technical specifications, general specifications, and apt price. You can find that over there and check whether it's the right price or not. So let's see another example. Yeah, so here is another Chevrolet car available, and we have the dealer and everything. We're going back to our application. So this is our application is all about. You can give us a call on this number, contact us over this thing, and this is our application is all about. And so towards the end, we have got like 43 makes, 246 models, 1,000 variants, and 546 reviews. If you got any queries, you can contact us. These are the members of our team. We are basically 4 members. So yeah, so we have it's Pramod, Prashant, that's me, Satish, and Vimal. And we thank you so much for your time, and any feedback and questions are welcome. Thank you.